Hello and welcome to our presentation. I'm Taiga Saito from the University of Electrocommunications in Japan. In this presentation, I'd like to talk about thermal sensation on forehead using electrical stimulation. A haptic presentation device can be added to the head-mounted display to provide a haptic experience in a simple way. In particular, the sense of temperature is important for enhancing the sense of presence. In addition, the widespread use of inexpensive HMDs has led to an increase in the number of virtual reality contents that require the wearing of HMDs. So we proposed the use of electrical stimulation to forehead to present temperature sensation. And in this experiment, we focused on cold sensation because thicker nerves are easier to stimulate by electrical stimulation. We used this electrical stimulator that consists of 61 circular. Diameter of each electrode was 1.2 mm, the center distance between the electrodes was 2 mm, the pulse width of the electrical stimulation was set to 0.5 milliseconds, and the pulse cycle was set to 11.0 milliseconds. 1 mm thick gel was applied at the center of the participant's forehead, and the electrode was attached using an elastic band. To decrease the effect of the gel on cold sensation, the experiment was conducted after the coldness of the gel was no longer felt. We investigated the point where electric stimulus generated maximum temperature sensation. The stimulus was applied cathodic stimulation of 1 mA to each electrode, and the participants reported whether the cold sensation was generated. The points that generated cold sensation was stimulated again, and participants reported the intensity of coldness on a 10-point scale from 0 to 9. The point that generated the coldest sensation was thus determined. This image is shown cold points for each participant by electrical stimulation. The blue points are places where the cold sensation occurred. The average number of cold points was 15.2, and the number had large deviations among participants. Among the 61 electrodes, the minimum number of cold points was 4, and the maximum number of cold points was 34. The point determined in the preliminary experiment was used as the stimulus point. 5 different current values were presented to the stimulus point, 5 trials for each in a random order. In each trial, the electric stimulus was presented for 5 seconds, and then the stimulus was stopped to measure the temperature, vibration, and pressure intensity. The overall average results is shown. The temperature, vibration, and pressure sensations increased slowly monotonically with an increase in current. And the comments from participants indicated that the cold sensation generated by electrical stimulation on the forehead was not felt as the spreading coldness of ice pressed on the forehead, but felt as the localized coldness of the area like the needle was pressed. Correlations of temperature, pressure, and vibration intensity with respect to the subjective evaluation of each value. The correlation coefficient between temperature and pressure intensity was 0.792, indicating a strong positive correlation. The correlation coefficients between temperature and vibration intensity, and that between pressure and vibration intensity, were 0.362 and 0.463. In conclusion, we proposed the use of electrical stimulation of the forehead to present a temperature sensation. Temperature, vibration, and pressure sensations increased monotonically on average. Cold sensation generated by electrical stimulation felt as localized coldness of the area like the needle was pressed. Thank you for your listening.